Hey, Mr. Harridan here. We're going to go over how to do a limiting reagent problem here. 35.6 grams of zinc are reacted with 100 grams of iron 3 sulfate here. So it doesn't even give me the products on this one. So we have zinc reacts with iron 3 sulfate. Iron is plus 3, sulfate is SO4 minus 2. So this is Fe2SO4 3. Since this is a single replacement reaction, we're going to have the zinc go with the sulfate. Zinc is plus 2, sulfate is minus 2, and iron is left out in the cold. We have 3 sulfates here, so we need to put a 3 here to balance. Now we have 3 zincs, so we have to have 3 zincs over here. We have 2 irons, so we need a 2 over here for the iron. Okay. So I know this is a limiting reactant problem here because I got 2 masses of my original reactants here. And I'm trying to find out the grams of pure iron. And I'm starting off with 35.60 grams of zinc. And I'm starting off with 100 grams of iron sulfate. So now we have to go down to moles for the zinc, over to moles, and then up to grams. But since I have a second amount of reactant here, I have to figure out which one of these is limiting. So I also have to take this one to moles, over to moles, and up to grams. Okay. So here I'm going to have to do 2 stoichiometries here. So I'm going to start off with 35.60 grams of zinc. And I'm going to convert it over to grams of iron. Grams on the top, grams on the bottom. What am I going to convert to? Moles. This is 1 mole. Going to do the molar mass here is zinc. I know it's 65.39. Okay, swish, swish. Now this is moles of zinc here, so now we got to do our reaction here. So this is the molar-mole ratio. Moles on the top, moles on the bottom. What are you going to convert to? Moles. This is moles of zinc. This is moles of iron. Wham, 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 wham. 3. Wham, 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 wham. 2. Okay. Swish, swish. Moles on the top, moles on the bottom. What are we going to convert to? Grams. Iron. Iron. 1 mole according to the tape. 55.85 grams of iron. That's the molar mass of iron. Multiply, divide, multiply, divide, multiply, divide. We get an answer of 20.27 grams of iron. Okay, now we have to do our other stoichiometry here, which is 100 grams of iron 2 sulfate, or iron 3 sulfate, sorry. And we draw our T-chart here. Grams on the top, grams on the bottom. What are you going to convert to? Moles. This molar mass is 399.91. This one is 1. 399.91. $399.91. Gee, moles. Got with the gangsters. Okay. Continue on here. This is moles of iron sulfate here, so we have to do moles down here and moles up here. That don't make sense. Gotta cross out my moles. Iron sulfate up here. And iron here. This is 1. This is 2. Moles on the top, moles on the bottom. What are we going to convert to? Grams. 1 mole here, 55.85 grams there. And we get an answer of 27.93 grams of iron. Okay, what does this all mean here? Notice that this is the lower number right here, the 20.527. Since this is the lower number, this is the iron that was actually made, which tells me that the zinc is limiting. The zinc was all used up in this reaction. This 27.93 is the iron that didn't happen. Could have happened if you had the perfect amounts of zinc and iron sulfate, but you didn't have the perfect amounts of zinc and iron sulfate, so that means that this is the excess reactant, which is the iron sulfate. Okay? So how much actually was made? 20.27 grams of iron. Okay? Which was the limiting reactant? Zinc. How do you know? Produced lower amount of product. Which means if you started off with 35.60 grams of zinc, that's where you started, and you ended up with 0 grams of zinc, and that must means we used 35.60 grams of zinc. Okay? That's what it means when it was a limiting reagent. It all gets used up in the reaction, leaving us with none left over. Okay? What is the excess reactant here? Well, the excess reactant here is the iron 3 sulfate. How many grams was used? Okay, so what I actually do here is I do question D first. How much of the excess reactant was left over at the end of the experiment? Okay, I do this first. Okay, let me explain how I'm going to do this. Okay, so we could have made 27.93 grams of iron, correct? That didn't happen. Right? We actually made 20.27 grams of iron, which was made. So, if you subtract these two numbers, right? 27.93 minus 20.27, this gets me 7.66 grams of iron not made. If I had the perfect amounts, I would have made that, but I didn't, so this is not made. So this is what I'm going to do. I'm going to take this number and stoic this back to the iron sulfate. So for step D here, this is what I call a subtract and stoic. You subtract your amounts of products here. 7.66 grams of iron is what I ended up with. And we are going to stoic back to the grams of iron sulfate. Okay. Grams on the top, grams on the bottom. What am I going to convert to? Moles of iron. 55.85, 1 mole of iron. Okay. Moles on the top, moles on the bottom. What are we going to convert to? Moles. There was 2 moles of iron per 1 mole of iron sulfate. Moles on the top, moles on the bottom. What are we going to convert to? Grams. Molar mass is 399.91 grams, and this is 1 mole. And we get an answer of 27.42 grams of iron sulfate. what does that actually represent? This represents the iron sulfate that is actually excess. So that is an important number here. And this is an important number here. So what does this mean? So if you started off with 100 grams of iron 2 sulfate and you ended up with excess, this is the excess, 27.42 grams of iron sulfate, if you subtract 100 minus 27.2, you end up with 72.58 grams of iron sulfate, which is the stuff that you actually used. So I get the answer for D first, and then I go back and get the answer for C. Okay? Okay. Now, what is the identity of the other product? How many grams of it can be theoretically produced? Okay. So the other product here was zinc sulfate. Okay. Now there's two ways to do this calculation here. There's many ways to do this calculation here. So you're trying to get to grams of iron sulfate here in this one. You can start off with one of two numbers. You can start off with the 35.60 grams of zinc because that was the limiting reagent that all got used up. Or you can start off with the 20.27 grams of iron because that is what is produced when 100% of the zinc reacts, because this is the limiting reactant. I usually vary how I do this, but I'm going to use the 35.60 grams of zinc, and I'm going to convert that over to grams of zinc sulfate. Grams on the top, grams on the bottom. What am I going to go to? Moles. 65.39, 1 mole. Moles on the top, moles on the bottom. What are we going to convert to? Moles. That don't make sense. This is zinc, and this is zinc sulfate. Now I gotta go back to my whams. 3 zinc sulfates, 3 zincs. I wish I could reduce to 1 and 1 if I really wanted to. Okay, that's nice, Mr. Harriman. And then 1 mole of zinc sulfate. And then the molar mass of zinc sulfate is 161.46, if I can read my paper. That's the molar mass of zinc sulfate. And you end up getting an answer of 87.90 grams of zinc sulfate. Okay? List off all the substances and amounts theoretically left at the container at the end of the reaction. So here's our container. That's my beaker. Remember, I have reactants and I have products. So first we'll look at the zinc here. Zinc was the limiting reactant. We ended up with 0 grams of zinc. The excess reactant was the iron sulfate. We ended up with 27.42 grams of iron sulfate. Oh, you can't see what I'm writing. Awesome. Okay, we produced 20.27 grams of iron from the zinc, because the zinc was a limiting reactant. So this is 20.27 grams of iron, and that would have produced 87.90 grams of zinc sulfate. Okay, the reaction was conducted in a laboratory setting, and we got 19.64 grams of pure iron were experimentally. What is percent yield of the reaction here? So, percent yield. is experimental over theoretical times 100. Since we are doing iron here, the experimental here is 19.64 grams of iron over 20.27 grams of iron times 100, which equals 96.89% grams, no, percent yield for your reaction. Okay, guys are champions. The legend is out.